Today we are going to learn about non-terminating. Before going to learn about non-terminating recurring decimals, first we have to learn that's very important. Clear? You learn about just like it's a recapitulation. The classification of decimals will be as used as two kinds, as you know it. The decimal and terminating decimals. So when it is a terminating decimal, there is no need to discuss about that. But when it is a non-terminating decimal, again it is classified as two kinds, that is a recurring decimal and non-recurring decimal. From this flow chart, it's very clear the decimals is classified as two kinds, that is terminating and non-terminating, and non-terminating will be classified as recurring and non-recurring decimals. Just we will observe all these kinds with examples. Okay. Let's take some examples about all these things. The first one as a non-terminating decimal. When you observe this, 2.5467251 and so on. When you observe dotted lines or dotted things in a decimal, simply you can identify it as a non-terminating decimal. When the division process is going on, there is no endless. It is continuously going on. So that's the reason we call it as a non-terminating. Let us observe one more example, 0.33333. It is also non-terminating. But what is specific thing here? A digit, that is 3, is continuously repeated. So that's the reason we call it as this kind of decimal as a recurring decimal. Now we will observe one more. That is a very familiar thing. That is value of pi. The senior mathematicians and famous Indian mathematician Ramanujan find the value of pi, and so many books have written on the value of pi also. I have taken a small example, means small value means up to 20 digits of pi. It's not a complete value, just up to 20 digits. When you observe it pi, that is 3.14159265397 and so on, just is only up to 20 digits. So here a digit or a group of digits are not repeating continuously, but there is no end, so it is a non-terminating. The digits are a group of digits not repeating also, so it is a non-repeated, non-terminating. It's a non-recurring, non-terminating decimal. So later you learn it as this one as a irrational number. Clear? So a non-terminating, non-recurring decimal we call it as a irrational number. But we have observed one more decimal, that is terminating decimal. When you observe 3.5 or 0.46 or 45.876, it's very clear. So 3.5 after decimal only 5, there is no other value, so it's a terminating. Even 0.46, so after 46 there is no other value. So these kind of decimals are said to be terminating decimals. So it's very clear. So we have terminating decimals, non-terminating decimals, recurring decimals and non-recurring decimals also. So when the value is given, you can identify whether it is a terminating or non-terminating. If I ask to you 0.6464646464 and so on, which kind of decimal it is? It's simply recurring decimal. If you say 3.46, which kind of decimal it is? It's a terminating decimal. Like you can say whether it is a terminating decimal or non-terminating decimal, whether it is a recurring decimal or non-recurring decimal, we can say very easily. Clear? Okay. So now we will observe what is a recurring decimal. Clear? We will take a clear meaning of recurring decimal. A recurring decimal is also known as repeating decimal. In a decimal, a digit or sequence of digits in the decimal part keeps repeating itself infinitely. Such decimals are called non-terminating repeating decimals or recurring decimals simply. Also, dot can be put over the first and the last digit of the repeat. Just now, I showed one example also for recurring decimal 0.333333 and so on, correct? So previous one, if you see that the previous one, 0. Decimal, observe it, it's a 0.33. 3 is repeating continuously, so it's a recurring decimal. A digit or a group of digits repeated continuously, such decimal is said to be as a recurring decimal. Clear? Okay. So if any decimal is given, we can identify whether it's a recurring decimal or not. Now let's take a small example. 1 by 7. So when you divide 1 by 7, the value is equal to 0.14285711, 142857, like. So here 142857, 142857, the group of digits are repeating continuously. So this is an example for the recurring decimal. Clear? Okay. When you consider 17 divided by 45, the value is 0.377777. Here 7 is repeating continuously. So it's a recurring decimal. Okay. Now how to get it? Just observe how to get it here. When you divide 17 by 45, so the quotient is 0.37. This is a method. So divide 17 with 45, so it's not possible, so we will take it as 0 point, then it becomes as 170, correct? So 45 3s are 135, so 35 is the remainder, so it becomes a 350. Take 7 7. When you take the division even infinitely, also the value comes infinitely, there is no end, so this is called a recurring decimal. Clear? Okay, so 17 by 45 you can write as 0.37 bar. So why you have written as 37 bar here? So 17 by 45 and 17 divided by 45, the quotient is 0.377 and the digit 7 is repeating here. So for instance, 0.37777 also can be written as 0.37. Already I said, so the repeating, just we will put a dot or a bar on that digit or group of digits which are repeated continuously. Clear? Okay. So we'll observe some more recurring decimals. Those are called as mixed recurring decimals. What is mixed recurring decimal? That's a very, very important. A decimal in which at least one of the digits after the decimal point is non-repeated and some digits are repeated is called a mixed recurring decimal. Just see this example. 0.27777. When it is divided by 18, the value is 0.27777. A 2 is not repeated, 7 is repeating here. So this decimal contains 2 which is non-repeated, 7 which is repeated. Means some digits are repeated, some digits are not repeated, means here it's a mixing of repeated and non-repeating. So this kind of decimal we simply call it as a mixed recurring decimal. Just observe one more example, that is 5 by 16, 5 by 6, sorry. So 5 by 6 is equal to 0.833333. Means here 8 is a non-repeated digit, 3 is a repeated digit, contains non-repeated and repeated decimals. So we call it as simply is a mixed recurring decimal. Clear? Okay. So how to convert a recurring decimal into fraction? So that's a very, very important area. So first let us take with an example, that is a 0.38 bar, 38 bar. So we have bar and 38. Means so 38 is repeating continuously. Okay, so for this kind of problems, we will say let n equal to 0.38 bar. Means n value 38, 38, 38, 38, 38 and so on, correct? Okay, so according to the number of digits which are repeated, so we have to multiply that number with the multiples of 10. If there is only one digit is repeating, then you have to multiply with 10. If two digits are repeating, then you have to multiply with 100. Three digits are repeating, we have to multiply with 1000. In this process, you have to multiply. Here, 38, two digits, you have to multiply with 100. Then, the value becomes as 100 and equal to 38.38. And n is, as you know, that it's 0.3838. So when you subtract n from 100n, we'll get 99n, which is equal to 38.38 minus 0.38, which is equal to 38. So 99n equal to 38 and n equal to 38 by 99. In this manner, we can convert a recurring decimal into a fraction. I will give a small idea. This is a small tip to here. Simplest way without doing all these things here. So 0.38 bar. So here remove the decimal part and write only the digits. That is the number which contains after decimal, that is 38. So write 38. Under the bar, how many digits are there? Two digits are there. So for each digit you have to write 19. So there are two digits, so 99. So write 38 as a numerator, 99 as a denominator will be 38 by 99. In this manner, you can say very easily to convert a recurring decimal into a fraction. Clear? Okay. So now if you go on this, we'll go for one more example. The equivalent fraction is 38 by 99. Clear? Okay.